So what is RMS? Root mean square, or RMS, refers to the most common mathematical method of defining the effective voltage or current of an AC wave. Most books define this as the amount of AC power that produces the same heating effect as an equivalent DC power, or something similar along these lines. But an RMS value is more than just that. The RMS value is the square root of the mean value of the squared function of the instantaneous values. The symbols used for defining an RMS value are VRMS or IRMS. The term RMS only refers to time-varying sinusoidal voltages, currents or complex waveforms where the magnitude of the waveform changes over time and is not used in a DC circuit analysis or calculations where the magnitude is always constant. When used to compare the equivalent RMS voltage value of an alternating sinusoidal waveform that supplies the same electrical power to a given load as an equivalent DC circuit, the RMS value is called the effective value and is generally presented as VF or IF. In other words, the effective value is an equivalent DC value, which tells you how many volts or amps of DC that a time-varying sinusoidal waveform is equal to in terms of its ability to produce the same power. For the next slide, this is a periodic waveform called the sinusoidal waveform. Can you guess what's the value of this waveform? The value is 0. Now, this is an average formula. Can be used for current and voltage. This will determine the mean of the waveform. Onto the next formula is the RMS, which means the root of the mean of the square of a waveform. This basically squares the mean, which usually makes the value of the waveform positive.
So we have here an example of a sine wave. Ang y-axis natin ay v theta, v of theta, at ang x-axis natin ay theta, which is in radians. So ang period natin, nag-stop siya sa 2 pi. Ang kailangan natin, yung v of theta, which is equal to Vm sine theta. So yung Vm natin na ito, yan ay yung peak voltage or yung maximum voltage. So pwede natin gamitin Vp or Vm. Okay. So VRMS niya is equal to yung root, yan, and yung mean, which is yung diniscuss ni Jamie kanina, at squared. So root, mean, squared. So palitan lang natin itong t ng 2 pi kasi yan yung period natin. So 1 over 2 pi square natin h Vm squared sine squared theta d theta. So itong Vm squared natin, pwede naman natin siyang ilabas dahil constant siya. May value siyang given. Ayan. So what we have left inside the integral is sine squared theta d theta. So it's easier to evaluate this integral kung papalitan natin siya ng trig identity. So equivalent to sa 1/2 times 1 minus cosine 2 theta. Equivalent lang siya. So itong 1/2, constant naman siya. Pwede natin siyang ilabas. What we have left is 1 minus cosine 2 theta. So, itong 1 minus cosine 2 theta, pwede man natin siyang i-evaluate ng hiwalay para madali. Itong 1, ang integral lang ng 1 d theta ay theta. At ang integral lang ng cosine 2 theta ay sine 2 theta over 2 or 1/2 sine 2 theta. So, na-integrate na natin sila. Next ay evaluate natin from 0 to 2 pi. So, theta from 0 to 2 pi minus 1/2 sine 2 theta from 0 to 2 pi. So, 2 pi minus 0 minus 1/2 sine 2 times 2 pi minus sine 0. So, ito kahit di na natin ito i-calcu, mapapansin nyo naman 2 pi, ito yung period ng waveform natin. So, isang buong sine wave siya. So, ito times 2 lang natin siya. Pag drawing nyo, papansin nyo, babalik lang siya sa 0. So, this is equal to 0 lang. That's 2 pi minus 1/2 times 0 minus 0. So, cancel na to. Dahil anything times 0 is 0. Ang natira na lang ay 2 pi. So, let's plug this value in our former equation, which is ito. That will be the square root of Vm squared over 2 pi times 1/2 times 2 pi. So, cancel na tong 2 pi. Ang matitira na lang ay square root of Vm squared over 2. Our final answer will be Vm over square root of 2. So, ito na yung na-derive nating equation para sa RMS value ng sine wave. Okay, so for example, binigyan tayo nitong sine wave at yung value ng Vm niya or yung peak voltage natin ay 20. So, anong RMS value niya? Lagay lang natin yung equation na na-derive natin kanina, which is Vm over square root of 2. Substitute natin Vm ng 20. So, that will be 20 over square root of 2. Our final answer then will be 10 times square root of 2 volts or 14.142 volts. So, tandaan nyo itong value na to kasi may mapapansin kayo mamaya kapag kinuha na natin yung RMS value ng cosine na waveform.
Ngayon naman po, ang i-discuss natin ay ang RMS ng cosine wave. Yung RMS ng cosine wave ay parehas lang sa RMS ng isang sine wave. Ang pinagkaiba nga lang nila is yung cosine wave ay 1/4 cycle or 90 degrees na mas maaga or earlier kesa sa sine wave. Ngayon naman ipakita natin yung proof ng RMS ng cosine wave gamit yung general expression para sa RMS ng isang sinusoidal wave. So VRMS equals the square root of 1 over t or yung period times the integral of 0 to 2 pi, so isang cycle, Vm or yung Vmax or your Vpeak cosine theta squared d theta. Ngayon yung period na yun 2 pi, yun yung t 2 pi siya. Ngayon lalabas natin si Vmax 2 multiplied sa 1 magiging Vm squared over 2 pi yan. Tapos evaluate natin yung integral ng cosine squared. Ang ating magiging equation ay square root of Vm squared over 2 pi times or quantity 1/2 times theta plus 1 over 2 sine 2 theta. Tapos, huwag natin kalimutan yung ating limit na 0 to 2 pi. So, evaluating the limits, we have the square root of Vm squared over 2 pi, quantity 1/2. Unahin muna natin yung 2 pi. So, distribute lang natin. 2 pi plus 1/2 sine 2 times 2 pi minus quantity 0 plus 1/2 sine 2 times 0. So, evaluate natin yung 1/2 sine 2 times 2 pi. Yan ay 0. Tapos, yung 0 plus 1/2 sine 2 times 0 is equal to 0 pa rin yan. So, magiging equation nating susunod is square root of Vm squared over 2 pi times 1/2 times 2 pi. 2 pi na lang kasi cancelled na yung 1/2 sine 2 times 2 pi at saka yung 0 plus 1/2 sine 2 times 0. So, yung susunod natin equation is square root of Vm squared over 2 pi times 2 pi over 2. So, cancel out natin si 2 pi. Ang kalalabasan niya ay square root of Vm squared over 2 or Vm over the square root of 2 or Vm times 0.7071. So, yun yung formula ng pagkuha ng ito yung formula ng pagkuha ng RMS ng cosine wave. So, mapapansin nyo, parehas lang sila nung sine wave. Vm over the square root of 2. Okay, so meron tayong example. Find the RMS or effective voltage of the cosine wave with a voltage peak of 20 volts. So, gamitin natin dito is yung general expression. So, plugging in the values. So, meron tayong VRMS equals the square root of 1 over 2 pi times the integral from negative pi over 2 to 3 pi over 2 20 volts cosine theta squared d theta. So, kung mapapansin nyo, nag-iba yung limits natin. Kanina, doon sa general expression, 0 to 2 pi. Ngayon dito, negative pi over 2 to 3 pi over 2. So, kung titingnan natin yung graph, makikita natin na yung unang half cycle, yung complete na half cycle is mula doon sa period na pi over 2 to 3 pi over 2. So, yun yung kukunin natin, yung peak kung saan naroon yung peak. Kukunin natin yung RMS niyan. So, evaluate natin. VRMS equals square root of 1 over 2 pi times the integral of negative pi over 2 to 3 pi over 2 20 squared cosine squared theta d theta. 20 squared is equals to 400. So, ilalabas natin 400 kasi constant naman na siya. Tapos, multiply natin siya sa 1 over 2 pi. Magiging 400 over 2 pi na yan. So, next, magkakaroon tayo ng square root of 400 over 2 pi times the integral of negative pi over 2 to 3 pi over 2 cosine squared theta d theta. Ngayon, evaluate naman natin yung integral nung cosine squared theta. Integral ng cosine squared theta is 1/2 times theta plus 1/2 sine 2 theta. So, magkakaroon tayo ng equation na the square root of 400 over 2 pi quantity 1/2 times theta plus 1/2 sine 2 theta. Huwag nating kalilimutan yung mga limits na negative pi over 2 to 3 pi over 2. So, evaluate natin yung limits. Unahin muna natin yung 3 pi over 2. So, plug in lang natin yung mga yan. So, magkakaroon tayo ng the square root of 400 over pi times 1/2 times quantity 3 pi over 2 plus 1/2 sine 2 times 3 pi over 2 minus quantity negative pi over 2 plus 1/2 sine 2 times negative pi over 2. Evaluate ulit natin. So, pagkasamahin natin lahat ng denominator niya. So, magkakaroon tayo dito ng 3 pi plus sine 3 pi over 2 minus negative pi plus sine negative pi. So, alam natin na yung sine 3 pi at yung sine negative pi is equals to 0. So, magsi-0 lang yan. So, ang kalalabasan na lang yan is 3 pi over 2 and negative pi over 2. So, meron tayong equation na square root of 400 over 2 pi times 1/2 times 3 pi over 2 minus negative pi over 2. Okay, so dahil sa negative times negative, magiging positive yan. So, i-add natin siya sa 3. So, i-add natin itong dalawa, 3 pi over 2 plus pi over 2. So, magiging 2 pi po yan. So, next nating equation ay magiging square root of 400 over 2 pi times 1/2 times 2 pi equals square root of 400 over 2 pi times 2 pi over 2. So, yung answer natin is square root of 200 or 10 the square root of 2 or 14.14213 volts. So, yun po yung effective voltage ng ating cosine wave na may voltage peak na 20 volts. Ngayon, check naman po natin yung sagot natin kung tutugma siya dun sa general formula ng sine and cosine wave. Kasi nga, di ba yung sine and cosine, parehas lang sila ng formula na Vm over square root of 2 or Vm times 0.7071. Ayan, Vm over square root of 2, plug in lang natin yung Vm na 20 volts kasi yan yung Vmax. So, ang magiging sagot niya is 10 square root of 2 or 14.14213 volts. Same din sa kabila. At yun po yung RMS ng isang cosine wave.
So, for this example, let's try to find the RMS value of a square wave. The first thing that we should notice is that it has a period of pi. Meaning na sa isang wave na to, meron tayong period of pi. And we should also notice that we have a piecewise linear function, v of t, with a value of 4 between 0 and pi over 2, and 2 between pi over 2 and pi. So, ibig niya sabihin, sa unang half wave na to, meron siyang value of 4 between 0 and pi over 2. And sa pangalawa namang half wave, meron siyang value of 2 between pi over 2 and pi. Then, diretso na tayo sa formula. Insert natin yung given. The RMS is equal to the square root of 1 over pi, the integral from 0 to pi over 2 for squared dt, plus the integral from pi over 2 to pi to squared dt. And then 4 squared dt is 16 dt and 2 squared dt is 4 dt. Then let's take the antiderivative of 16 dt and 4 dt. Since constant lang siya, ang kanyang antiderivative will basically be 16t and 4t. Then let's evaluate 16t from 0 to pi over 2 and 4t from pi over 2 to pi. Then we will have this equation. 16 times pi over 2 minus 16 times 0 will give us 8 pi. And 4 pi minus 4 multiplied by pi over 2 will give us 2 pi. And then, isolve na lang natin siya. 1 over pi times 8 pi plus 2 pi is 10. And the square root of 10 is 3.16 volts, which will be our final answer.